Hello everyone. So today we are going to solve the problem of the day, nCr, in which we have been given two integers n and r, and we have to find nCr. And they have said that answer may be very large, so we have to calculate it with the modulo 10 to the power 7 plus 10 to the power 9 plus 7. All right. So we are given that n equals 3 and r equals 2. So let us understand through the very first test case in which we have n is 3 and r as 2. So we know the formula that nCr is nothing but n factorial, which is nothing but 3 factorial, divided by n minus r factorial, which is n minus r is 1, right? 1 factorial multiplied by r factorial, which is nothing but 2 factorial. So this would come out to be 3. So the output is 3 itself. So how do the way we are going to approach this problem is first to build up a ta table and observe the pattern, how we are getting our answers, right? So I've already created one, and in which let us understand if my n was 0 and r was 0. So clearly 0 factorial is 1. We all know that. So we fill it with 1. And now they have given that if our r is greater than n, we return 0. All right. So here we return 0. By the way, this r is the columns and n is rows. All right. So for n equals 1, we have 1 factorial, right? Which is nothing but 1. 1c0 is 1. All right. And 1c1 is again 1 itself. And 1c2. So r is greater than 1. Right, so we fill it with 0. Similarly, for 2, 2c0 is nothing but 1, and 2c1 is nothing but 2 itself. And 2c2 is 1 again, and 2c3 is 0. So if you find it difficult finding out the NCR, you may try it in pen and paper and you will surely get it. So let us moving on. 3c0. 3c0 is nothing but 1. And 3c1 is nothing but 3. All right. And 3c2 is again 3. And 3c3 is 1. Right. And 3c4 is 0. So this is nothing but if you have studied permutation and combination in 11th and 12th standard, you might have studied the Pascal's triangle. And this is nothing but the Pascal triangle itself. So what is happening in this case is this digit, uh, since the permutation, very first NCR is 1 itself and followed by a 0. Now we fill it from here. So if this is nothing but, as you can see the pattern, the next element, the next diagonal element is nothing but the sum of these two elements. All right, 0 plus 1 is nothing but 1. And again, this diagonal element, which is nothing but this one, is nothing but sum of these two elements, right? So this is it, 1. And again, this diagonal element is nothing but sum of these two elements, these twos. 1 plus 1 is nothing but 2. Now again, we have to find out this diagonal element. So 0 plus 1 is nothing but 1. And 1 plus 2 is nothing but 3. And 2 plus 1 is nothing but 3 again. And the 1 gets carried on along the column, right? So I hope you get the intuition of this problem, how we are getting the new results one by one. So what we can do is we can simply calculate the answer as answer equals to, we can use recursion for that, and recursion will calculate the answer as the, suppose if I write a function, suppose recur of, my bad, recur of This is nothing but, so we will fill it. We will fill these r equals 0. We will handle all these base cases and fill it with 1. And if our r goes increasing, if our r is greater than n, then we fill it with 0. And we will calculate our answer as answer of, what was our answer? It was nothing but the sum of above two elements, the above element and the diagonal element, right? As you can see, the, let me erase and then again tell you. So as we have seen that this one was nothing but sum of this 0 and this one, right? So this was nothing but the element above it, which is nothing but n minus 1 comma r, n minus 1 comma r, right? R is same and n is changing by 1, and plus plus n minus 1 comma r minus 1, right? Which means it's sum of the diagonal element and the element above it. So our sum will be calculated like this, and we will return it with the mod operation. Right. So let us first try the brute force, then we'll move on to the memoization. Okay, we will be optimizing it. Since the time complexity is factorial in this case, so let me first write the recurve function in which we'll be passing our n and r. And now let me write the recurve function itself. So let us first handle the base cases. If our r is greater than n, then we simply return 0. And in this case, if our n is equal to r, or our r is 0, then we return 1. And similarly here also, if our r is greater than n, then we return 0. And at last, we return our the sum of the above element. The next element would be nothing but the sum of above element and the diagonal element, right? So the sum of above element would be nothing but n minus 1 comma r plus vector of n minus 1 comma r minus. I hope you get the idea how we are getting the new element. And since the answer might be very large, so we'll be taking the mod. So let me define the mod. Right. So the mod would be nothing but 1e9 plus 7. So let us compile it and check if we did any mistake. So this, so it is working fine. Now, if you submit this code, this will surely get TLE. So let us optimize it. So we'll be using the memoization, in which the very first step is to create an array. And what will be the parameters of this array? So it would be nothing but the number of parameters which are changing, right? So clearly the changing parameters are n and r, right? Since they are changing throughout this code. Okay. So let us create a 2D array, which will be nothing but vector of ring, and the name would be, suppose, the output, and the size of this array would be n plus 1 comma vector of int n plus 1 comma, let us initialize it with -1. And now let us pass it to our function, right? So we have passed it, and now let us receive it by reference, right? So we have received it. Now, before returning our answer, let us check if answer exists. Yes. answer exists. So what I will be doing is saving our answer. So for checking if the answer exists, what I'll be doing is if my output at a certain index is not -1, right? Is not equal to -1, then I return output of that index, which means my answer is saved there. Now let us here save the answer. So output of R and N will be equal to 1. And similarly in this case, and similarly for in this case 2. So let us now compile and run. Oh, I did a mistake. I have not passed the output array while calling the recursion. So now let us compile and run and check if we have made any errors. So it is working fine. Let us submit. All right. Thank you.